Welcome to today's paper reading. Today's paper is titled, GPT-4V, ision, as a generalist web agent, if grounded. This paper was published on the AR14 preprint by Boyuan Zheng and colleagues from The Ohio State University. The recent advancements in large multimodal models, such as GPT-4V and Gemini, have significantly expanded the capabilities of these models beyond traditional tasks like image captioning and visual question answering. In this work, the authors explore the potential of GPT-4V as a generalist web agent capable of following natural language instructions to complete tasks on any given website. They propose CACT, a web agent that leverages the power of large multimodal models for integrated visual understanding and acting on the web. The evaluation is conducted on the Mind2 web benchmark, and the authors introduce a new online evaluation setting by developing a tool that allows running web agents on live websites. The results show that GPT-4V has great potential for web agents, successfully completing 51.1% of the tasks on live websites when manually grounded. However, grounding remains a major challenge, with existing strategies proving ineffective, and the best strategy developed in this paper leverages both HTML structure and visuals. There is still a substantial gap compared to Oracle grounding, indicating ample room for further improvement. In this work, the authors aim to investigate the potential of large multimodal models, LMMs, as generalist web agents. A generalist web agent is defined as one that can follow natural language instructions and complete tasks on any given real-world website. These tasks can be quite diverse and complex, often requiring over 10 actions across multiple dynamically rendered web pages. To address this, the authors propose CACT, a web agent that leverages LMMs for integrated visual understanding and acting on the web. They focus on GPT-4V, the most advanced LMM publicly available, and compare its performance with smaller LMMs like BLIP-2 and LLMs 1.5. One of the major challenges identified is grounding, which involves converting textual plans into precise actions on the website. This includes selecting the correct HTML element to interact with and determining the appropriate operation. The authors propose various grounding methods and evaluate their effectiveness, finding that leveraging the known correspondence between HTML elements and their visual rendering is particularly effective for websites. Figure 1 illustrates the CACT framework, which utilizes an LMM like GPT-4V to visually interpret websites and formulate plans in textual format. These textual plans are subsequently grounded onto specific HTML elements and operations, enabling actions to be performed on the website. In this section, we discuss the problem formulation of web agents and introduce CACT, a generalist web agent based on large multimodal models, LMMs. Given a web-based task on a specific website, the agent needs to generate a sequence of actions to complete the task. At each time step, the agent generates an action based on the current environment observation, previous actions, and the task. The environment observation includes an HTML document and a screenshot image. LMMs can be grounded on both the HTML document and the screenshot image. The action generation process involves generating a textual description of the intended action, which is then converted into an executable action through a process called action grounding. This section also explores 3 approaches to element grounding, via element attributes, textual choices, and image annotation. Figure 2 illustrates the element grounding process for a single action in a web agent task, focusing on clicking the Find Your Truck button. The figure showcases 3 different grounding methods: textual choices, image annotation, and element attributes. In textual choices, the model selects from HTML text representations of elements. Image annotation involves adding bounding boxes and index labels to the image, with the model identifying the label of the target element. Element attributes method requires the model to predict both the text and type of the target element. Each method aims to accurately identify the HTML element necessary for the action. In this section, we discuss the experimental setup and evaluation methods. The experiments are conducted on the Mind2 web dataset, which includes over 2,000 complex web tasks across 137 websites and 31 domains. The dataset supports 3 primary operations: click, type, and select. For evaluation, we focus on metrics such as element accuracy, ELE, ACC, and operation F1, OP-F1. The methods employed include CACT, which uses the BR database, MINACT with FLAN-T5 and BLIP-2 T5, and pixel-level grounding using COG agent. These methods are crucial for assessing the performance of web agents in various scenarios. Table 1 provides a detailed overview of the multimodal MIND2 web dataset, which has been cleaned and aligned with corresponding web page screenshots. The dataset is divided into 4 splits: train, cross-domain, cross-task, and cross-website. Each split has varying numbers of tasks, domains, and websites. The average number of actions and HTML elements per task is also provided, along with the average number of visual tokens based on the OpenAI Visual Token Calculator. This table is crucial for understanding the dataset's composition and the complexity of tasks it encompasses. In this section, we discuss the results of using GPT-4V as a generalist web agent with Oracle Action Grounding. The model achieved step success rates of 61.9%, 65%, and 62.1% across 3 test splits, showing a significant improvement over other methods. Specifically, it outperformed the second-best method by 8.4% in the cross-task setting and by 23.9% and 23.2% in the cross-website and cross-domain settings, respectively. We also compared different grounding methods, finding that SEACT choice performed the best, while SEACT annotation showed severe hallucination issues due to GPT-4V's difficulty in understanding image details. Additionally, SEACT attributes effectiveness was limited by its heuristic-based localization strategy. When comparing large multimodal models, LMMs, with large language models, LLMs, SEACT choice with GPT-4V demonstrated a substantial performance advantage over GPT-4, outperforming it by 6.8%, 5.7%, and 12.3% in 3 settings. Interestingly, BLIP-2 T5, despite having additional visual input, did not show a noticeable gain over FLAN-T5, likely due to limitations in the CLIP model's ability to comprehend image details. Table 2 presents the performance metrics of various models across different test splits. The CACT framework, utilizing choices for grounding, demonstrates superior performance compared to other models. Notably, the GPT-4V Oracle method, which employs Oracle grounding, achieves the highest step success rates, significantly outperforming other methods, especially in the cross-website and cross-domain settings. This table highlights the importance of effective grounding methods for enhancing model performance in web navigation tasks. Table 3 presents the step success rates of GPT-4V across a subset of 30 tasks, differentiated by various grounding methods. The methods include attributes, choices, annotation, and Oracle, which correspond to different techniques of element grounding. Notably, SEACT Oracle demonstrates the highest success rates, particularly in the cross-domain setting, where it significantly outperforms other methods. This table highlights the impact of grounding techniques on task performance, with Oracle grounding showing the most effective results. Table 4 presents the whole task success rates under both offline and online evaluation conditions. Offline 0 indicates no tolerance for any errors at any step, while offline 1 allows for 1 error. The online evaluation involves human monitoring of agent actions to determine task success. The table highlights the significant improvement in success rates when tasks are evaluated online compared to offline, suggesting that offline evaluations may underestimate the true success rates due to the variability in possible action plans. Figure 3 illustrates the whole task success rate across different task difficulty levels, categorized by the number of actions required to complete the task. Tasks are grouped into easy, 1 to 4 actions, medium, 5 to 9 actions, and hard, 10 to 18 actions, with 37, 35, and 18 tasks in each group, respectively. The success rate is negatively correlated with the number of actions, indicating that as tasks become more complex, the success rate decreases. SEACT Oracle consistently outperforms other methods, showing a significant gap in performance, especially on longer horizon tasks where grounding errors can cascade to later steps. In the realm of web agents, several approaches have been developed. MindAct focuses on ranking HTML elements to manage the massive size of raw HTML documents. WebAgent enhances planning by summarizing HTML and breaking down instructions. Pix2Act uses visual information to complete GUI-based tasks. Moving to large multimodal models, GPT-4V and Gemini represent significant advancements. These models have shown remarkable capabilities in integrating visual and language reasoning, as evidenced by their performance on various benchmarks. However, despite these achievements, challenges remain in fine-grained visual grounding. Methods like visual prompting and fine-tuning with annotated data aim to improve the model's ability to ground image details accurately. In this study, the authors developed ZACT, a generalist web agent that integrates large multimodal models, LMMs, such as GPT-4V for visual understanding and web interaction. The research demonstrated a 50% success rate on live websites using an Oracle grounding method, highlighting the potential of LMMs for such agents. GPT-4V showed capabilities like error correction and speculative planning, but fine-grained visual grounding remains a challenge. The most effective grounding strategies still showed a 20 to 25% performance gap compared to Oracle grounding. Future work should focus on leveraging the web's unique properties, such as the known correspondence between HTML and visual elements, to improve grounding and reduce hallucinations from LMMs. Additionally, the study revealed a significant discrepancy between online and offline evaluations, emphasizing the importance of online evaluation for accurately assessing a model's capabilities. This discrepancy is attributed to the variability in potential plans for completing the same task, reflecting the dynamic nature of web interactions. The potential benefits of generalist web agents include automating routine tasks, enhancing user experiences, and promoting web accessibility. However, safety concerns are critical, encompassing privacy issues, sensitive operations, and the potential for harmful actions. During online evaluation, the possibility of harmful actions was noted, and all actions were manually validated for safety before execution. It is crucial for further research to thoroughly assess and mitigate these safety risks. The code will be released solely for research purposes under an OpenRail license, aiming to make the web more accessible through language technologies. The authors strongly oppose any potentially harmful use of the data or technology. Thank you for watching.